The oxidation of alcohols is really important because alcohols play such a central role in organic synthesis, and that oxidation chemistry is a real important aspect of that central role because the oxidation products are carbonyl compounds. Carbonyl functional groups occur widely. So what I'm suggesting is that several types of precursors can be used to make alcohols and then these alcohols can be oxidized to carbonyl compounds. And before we're done with this course, you'll understand that carbonyl compounds are really where the action is. So you need to be able to make those guys. And oxidation of alcohols is a very common way because alcohols can be readily prepared from several types of precursors. So let's look at the facts then regarding alcohol oxidation. Number one, just say it, there are many different oxidizing agents and many different oxidizing conditions using that variety of agents to oxidize alcohols. Good news for you guys, we are going to focus on two that are both chromium based. So there's not a lot to learn here in terms of the actual reagents. The ones that we're talking about will oxidize an alcohol that has a hydrogen on that carbonyl carbon. And we are just going to say generally chromium 6 based reagents will make a carbonyl compound. The exact chromium reagent we choose and the exact alcohol we start with will determine which of several functional groups we make. So let's be specific, and I'll show you which alcohols can be oxidized to which functional groups using which reagents. There are two reagents that we need to talk about. One of them is chromic acid. This oxidizing agent can be made using chromium trioxide together with aqueous acid and acetone. Acetone is a solvent, uninvolved in the reaction, but solvent in this case is important. The other one is sodium dichromate. Together with sulfuric acid and water. So when you see either of these sets of conditions, you know that we're talking about oxidation with chromic acid. And chromic acid oxidizes primary alcohols which would be RCH2OH, to carboxylic acids. It oxidizes secondary alcohols. This would be R2CHOH to ketones. The point is that chromic acid is a strong oxidizing agent, and it will take a primary alcohol as far as it reasonably can in terms of oxidation level, and secondary alcohols can only be oxidized to ketones. The second oxidizing agent that's based on chromium that we're going to learn, and by the way, I'm noticing that that needs a CR there, chromic acid. Compound called pyridine It's an amine base, so it can be protonated, and then it is pyridinium. And the chlorochromate is this, and in methylene chloride, which is anhydrous, primary alcohols are CH2OH are oxidized only one oxidation level up, not two. So the product is an aldehyde, not a carboxylic acid. And secondary alcohols are also oxidized, and you get the same product you would if you used chromic acid. So there's no difference in product for the secondary alcohols, but for the primary alcohols, pyridinium chlorochromate selectively oxidizes primary alcohols to aldehydes and stops, whereas chromic acid oxidizes primary alcohols first to aldehydes and then immediately to carboxylic acids. So these are the two key reagents that we will think about when we're talking about oxidizing alcohols in organic synthesis. Think of these guys. And think of this set. Primary alcohols to carboxylic acids, you use chromic acid. Either of these preparations. Primary alcohols to aldehydes, you'll use pyridinium chlorochromate, which we call PCC with methylene chloride. And rather than remember all of this stuff, it's just fine with me if you remember this guy. And so there you have a summary of it. Oxidation of alcohols, primary alcohols, and secondary alcohols. And, oh, did you wonder about tertiary alcohols? Because there's no hydrogen attached to the carbonyl-carbon in a tertiary alcohol, we're talking about this. We're saying it's absent. in tertiary alcohols, those compounds are not subject to oxidation under these conditions. So in a nutshell, primary and secondary alcohols oxidize with chromic acid or a version of chromic acid. Tertiary alcohols don't. Primary alcohols oxidize to either carboxylic acids or aldehydes, and secondary alcohols oxidize using either conditions to ketones.